Hello and good morning, and thank you so much for joining me in my shop here and keeping me company. And let me just say a little more about that. When I'm making these videos, I turn on the camera, I really do feel that I'm not alone in my shop. This can be pretty lonely work. If you're doing this alone in your shop and working away on your radio and facing all the frustrations you're facing, it can feel pretty lonely at times. And also, it's easy to let the frustration grow. When I turn on the cameras, it kind of keeps me on the straight and narrow. So thank you for watching this video and all my videos. I very much appreciate it. Now, yesterday when I was cleaning up the shop, getting ready to leave, one of the things I remembered to do was to unplug the radio from the... I don't like to leave things plugged in like this. I yanked on the cover, and that's what I got. I got it coming apart. There's no power in this right now, so I'm going to pull this out. It's time to put a new plug on here, a whole new cord. So, you know, it's a two-prong plug unpolarized. Now you might say, well, why did they make things like this and not put three-prong plugs on them? And the answer is, certainly the house I lived in didn't have three-prong outlets. It had two-prong outlets unpolarized. So everything was built for a world without the third prong, and one side, well, both sides the same size, just like this. Well, time has gone by, things have changed, standards have improved, and now we could put a three-prong cord on here, which is what I'm planning on doing. Actually, got it right here, three-pronger. But it raises a couple of interesting questions. So the chassis is connected to the power line through two capacitors, one from each leg. They're sitting right here. The two capacitors come off the two power lines, and then they connect to the chassis. Well, if I introduce a third wire, the green wire, what am I going to do with that? Obviously I'm going to attach it to the chassis. Is that going to make any difference in the radio's operation? It's not what they intended. The engineers had nothing like that in mind, because it didn't exist back in their time when they were doing this. And you know, while I'm sitting here chatting, I've noticed something I better deal with. There's a whole pile of solder down here from a solder splash. Ooh. Don't want that floating around inside the back of the radio. Okay. Any others in there? Don't see anything. So what I think I'm going to do is I'm going to plug in the radio as it is, even with the crummy plug. I can do it safely. The plug itself is completely solid still. Look at this. You can twist it right around until the conductors contact each other. What's stopping that from happening? Nothing really. Yeah, not the best. For sure not the best. A little old. I'm going to plug it in. I'm going to read the voltage first to an earth ground. Now that's going to, I'll have to plug this into a regular outlet to do this. Well, we'll start with the isolated outlet. For my own sake, I'll do a little experiment here. This goes to an isolation transformer. I'm going to plug it in here. We're going to read the voltage from here to something ground. I keep pointing over here. I'm just meant there's a ground over here. I can put the voltmeter on. We'll see what's happening with the chassis voltage. There's actually a statement. I'm going to read it. I'm going to find it. There's a statement in the manual on this. I'm going to find it, and we're going to read it. Towards the back of the manual is a page called Additional Hints for the Novice and Shortwave Listener. Interesting document here, but this first paragraph is what I'm interested in reading. A voltage reading of 45 to 50 volts may be obtained between the chassis and the ground as a result of the two power line bypass condensers that are connected across the power line. Connected across the power line with the center tap grounded. When they say grounded, what they mean is connected to the chassis. Since we are dealing with AC, these capacitors will look like resistors to a voltmeter. This will also produce a slight shock if the chassis is not grounded, as one happens to contact a grounded object and the chassis or any exposed part of the receiver. This also will account for a slight spark if the receiver is connected to the power line and the ground connection is made. For protection, a good ground should always be employed. Okay, well, that last statement pretty well seals the deal for me. But you see, they are warning about the 45 to 50 volts that could be there in the receiver the way it is now. We're going to look for that voltage. Okay, let's give this a go now. The radio is plugged into an isolation transformer, and that means me taking a reading. What am I going to do here, actually? I have this connected to the chassis, and I really just, well, I'll leave this off. Well, I'm just going to put it on the ground over here, and we'll see probably a 50 or something like that. Then I'm going to switch the plug around and I'm going to put it in, but we may not see 50 because this is plugged into a isolation transformer. It's really, doing this measurement is a little akin to like grabbing a battery and thinking you can read it from one terminal. You can't read a battery from one terminal. So it's a little like that. Let's see what happens. Okay, and we're on. Okay, so I have one lead, clip leaded to the chassis. The other lead I'm going to put on the ground, and what do we see? Nothing at all. Really? Nothing? So I'm a little surprised. That suggests the isolation transformer is really, really good. I think there's something else going on myself. Let me read it right to the power here. Okay, get a reading. Okay, so there's 44. So, and the power coming over here is about 100 volts, so it should be something like 55, 60 over here. 40. 40 and 44. Oh, it's only 77 volts making it over here. So it's not even enough to actually power up the radio properly. Okay, so 44, 38, add them together, yeah, 70. Now, I really want to unplug this and plug it into a regular outlet and repeat this test more properly. So let's do that. Well, you don't have any dim bulbs to slow things down, but there's nothing wrong with this radio as far as I know. We can do this. So I want to be a little careful now that I don't touch these. Let me plug it in. Okay, it's in. Just a way, I don't know which way. So one of these will be ground and one of these will be live. We'll find out. I'm going to apply the power now. Okay, the set is on. And we will look. There's 120 volts there. And there'll be nothing over here. Okay. So what do we got on the chassis now? Okay, I'll just go to ground here. Nothing at all. Not quite what I was expecting. Nothing at all. Now I'm going to reverse the plug in the outlet here. Okay, here we go. It's back on again. What do we get this time? Chassis to ground. Yeah, nothing. Have I got a ground on here and don't realize it? I do. I do. I made a mistake here yesterday doing some testing. I put the ground for the meter on the chassis, which is probably a mistake. I probably should have had the ground on the B- line in here somewhere. what did it say in the, I think it said voltages were read to the chassis. Measured from tube socket to chassis. Now, are there many other connections to the chassis in here? I see lots of ground connections being made to the chassis all around these tubes. I see lots of solder right on the chassis. There's stuff here soldered right to the chassis. Okay, I'm making a big deal out of a pretty simple thing here, really. Not forget that this is switched on again. So we're reading, we should see 120 here. No? Didn't I turn it around? Still have the ground on here. That's the problem. Okay, so I'm going to pull it off. Okay, so I had this ground on. This is a 2-prong device. Still has 2 prongs on it, but I have a ground wire going to the case. A ground wire that's grounding all the equipment in my shop. Case grounding all of it. So let's try this now. So we're still in a regular outlet. We got nothing there. Wait a minute, this can't be the case. What am I reading to? I'm doing the reading the battery with one lead. So we want to, I'm really having trouble thinking here. We're going to measure the chassis voltage to ground. Now we're getting what I expect. So we're getting basically half of the 120. If this were 30 and then we took the other measurement and it were 70 or 80, then that would tell me these capacitors are no longer balanced in here. One of them is going out. But that's not the case. They're quite balanced. So no reason for me to think these capacitors are bad. That's part of what I'm looking at. Now if I put a ground on, is it going to cause a problem? If I put the green wire onto the chassis? I don't think it can. I think if this were made today, the engineers would have done that without hesitation. Does it matter which, like one of the 2 prongs is going to be grounded? Will it matter which one goes where? No, it won't matter because it doesn't matter now. I can put that plug in this way or that way. It doesn't matter now. It won't matter later. Do I have to give any consideration to that at all? And what I'm talking about here is because this has a ground prong on it, it can only go in the outlet one way. So this ensures that one of these is going into the grounded side. The grounded side is always to the left when you look at it this way. It's the left eye of the smiley face. Grounded one here. So with that certainty, should you do something different here? Like in a 5-tube radio, this is a much bigger problem. The radio with a transformer in it, it's really not. I really am making a big deal out of a relatively small thing. The other thing is, it's a beautiful day outside. By the way, the hurricane went by, turned into a day of rain. Lots of rain, but nothing to write home about really. Just a gray day, rainy, gray day. But today the sun is shining and I should be out there. Okay, even yesterday was fine. I gotta get this old cord out of here. So the first thing I gotta do, I gotta unplug this before I forget. Yeah, okay, that's out. Get the old cord out. This is quite stiff too, you know, the plastic has become stiff on it. So let's get rid of it. I'm not sure that was the best way to do this. The new cord is much bigger than the old cord, so I bet you I can't pull it out. Nope. are wondering what that roar is, that's my air conditioner coming on. It's a very nice arrangement here where the power cord comes in this radio, so this is really quite easy to work with. I'm going to probably try to undo these wires with the soldering iron. Now this hole, I can put the cord through the hole here. I got something that, I mean, this is meant for the little flat wire, not this big one. I don't know. I'm going to check into my stuff here, see what I got that I can strain relief that with. Okay, so this is a pretty big cord. This is the proper type to go in here, proper size, but it's made for the flat wire. It's not. You can't do this. And if you get one big enough, this is probably big enough here. This one's been around the block here. But even if you do, you can't fit it in the hole. I have to drill a new hole. I don't want to drill a hole. So I think what I want to do is bring this in and somehow fix it inside the radio so it won't pull out. Some clever way of doing that. Okay, so I'm going to work on that, and then I think what I'm going to do today, if I find, is verify or check into the alignment, the IF alignment in the radio. That's where I want to get to. Getting there kind of slow this morning. So I'm setting up the input connection for the signal generator to feed a 455 signal into the IF, and it says in the instructions, connected to the bus lead of the 6BE6. Bus lead, B-U-S. Bus lead. What is that? What is a bus lead? Now I'm sure they mean connected to the signal grid connection, and they don't want you to connect it to the local oscillator grid connection. There's two grid connections on this too. Bus lead. So I'm looking in the radio and wondering, well, bus lead? Bus lead? Well, can you see there's a bare, fairly large wire running through here? See this piece here? And on it is soldered some connections. And actually, this is the wrong bus lead. It's this one here. So they're calling these pieces of wire, which run right across here, buses, I guess. And in a sense they are, because you can make connections anywhere along them, which is kind of what a bus is, a place you can connect, like a bus bar, if that means anything to you. So that's what they mean, and so sure enough it's going to pin 7, which is the right 7. So all I got to do is just get on this big bus here, like so. I'm going to put this here, and this will be the connection for the signal generator output. So that's what's meant by bus in this radio. Well, I guess anybody doing this would figure that out soon enough. Is there a hum or a buzz in my audio here? What's going on? Let me just check with my own headphones. Nope. Nope. Okay. You know, I don't listen to the actual audio when I'm working in the shop. I don't put headphones on. That leads to a disaster sooner or later. So I don't actually hear what you're hearing. What I hear is just what my ears hear in the shop. Should be the same stuff, but not always. Okay, so that's the connection for the signal generator. It's just too floppy like this. This is no good. Can't have it like this. I don't want to go pretty busy over here. And there's a spot there I can get on. See, I can't keep an eye on this while I'm doing the work, so if this is going to flop over and do that kind of thing, I can't have that. So, making a connection to a bus. Hey, it's supposed to be easy. Okay, another way to do this is not go on the bus, but actually go right on the terminal here. That's way better. then we would bring the signal generator signal, and one side goes to the chassis, the other side's going to go here, but we'll connect it when we need it once we know the radio's operating properly. So that'll do two things. One is it'll rob the radio of its antenna signal, not that there will be one. I'm not going to hook anything up to the antenna, he says, as he disconnects the antenna connection. No, that's a speaker connection, Jim. That's not the antenna. This is the antenna. The antenna feeds into the center of the radio. Okay. Output. Oh yeah, okay. Output. Now, there, I gotta get a VTVM hooked up. The instructions are for monitoring the AVC voltage, which is what I actually like to do here. And I've still got something weird going on with the audio in my shop. Maybe it's this. Maybe if I do that. You know what? That's what it was. Okay, you don't even know what I did, but I did it. Now, right. Coffee time. That's obvious. It's coffee break time. Okay, I think we're all set to go. So I'm going to be using this meter, which is still warming up, which is why the 0 is not on the 0 at the moment. It's a long ways for you to see it. And we have the signal generator with the frequency set right now to 473. 455 is the proper IF. We do not have this connected yet. Is the radio working? Yes, it is. Okay, we'll leave it up a little bit. This is going to have a modulated signal. Let me calibrate this guy first here. So, calibrate. Okay, that's calibrated. 1000 hertz signal modulated at about 30% there. Okay. Now, next thing will be to connect the, to see this meter operating. Let me take off the input. You see it move from that distance? So there's already an AVC voltage there, a negative voltage. And this is on the 10 volt scale. So, 3 volts, roughly. Now, let me just touch the input here. You see this change. Oddly enough, it went down. I would have thought it would go up. It went down. Okay, we're going to hook up the signal generator here. Red lead. Input level is low. Here we go. Ooh. Volume is high. Volume down. Connect. Not a thing. Now, that's because we're still tuned outside of the IF. So I'm going to tune this down to the IF frequency. Right through it. Didn't hear a thing. Okay. This is the point where I go, well, something not right here. Something not right here. Let's increase the signal strength there. So that's 10 times stronger. There we are. Why the heterodyne? So I'm going to tune the radio just in case it somehow is picking up a signal here. Doesn't seem to be the case. Not sure why it's heterodyning like that. The tone I'm hearing, which changes pitch. Not supposed to be doing that. Why are you doing that, radio? I want to look at the front panel settings here, because you know what? I did not go through the settings to make sure they were correct. Duh. So one thing, the sensitivity is supposed to be somewhere else, I'm pretty sure. The limiter's off. The EQ multiplier is off. Antenna trim, I don't think that should make any difference. Oh, we're set to BFO from the last time I operated this set. So we're hearing the BFO. Oh, for crying out loud. Duh. Okay. Now all I'm doing is just checking to see if the IF really does respond to 455 properly. So I'm not doing the actual alignment here. So not going to change anything in the radio. I hear it now. Kind of quiet. So let's tune and see where it peaks up. Oh, looks like it's right on the money. Okay, I'm going to give it a little more juice. Now we can watch this meter. I'll raise the meter to the top here. There we are. And it's 456. So, I mean, it's bang on. Now, are all these aligned exactly to 455? I'll have to go in and adjust each one and see what happens, if it goes up or down. And another thing would be to put a sweep through it. Today I don't want to do the alignment. It's gotten too late in the morning and I want to get outside. But maybe I'll hook up the sweep generator and just see what we see with that. That'll only take a couple minutes. And gives me an excuse to go drink some more coffee too. Yeah. So far, wow, this radio's in really, really good shape so far. Okay, so I'm just finishing getting everything set up. So let's go through and check out what I've got going here. This is a sweep generator, and I've set it to start at 440 kilohertz and stop at 470 kilohertz. 40, 55. So that's basically puts 455 dead center of the sweep here. I'll turn it on, and you'll see it reports the center or the average number here, more or less. And you can see something going on the oscilloscope here. It's off center because the scope sweep is coming from this machine. It's not its own sweep anymore. I have the scope connection here to the same connection as the voltmeter. I just left the voltmeter connected. Don't know why, but I did. And we're going to be putting the input back in here, the sweep input, and then we'll watch on the scope and see what we get. And I got to warn you, about 50% of the time when I try this test, it completely fails. It just, one way or another, I get everything wrong and nothing works out. So right now we're going to just reduce the signal a fair bit. There's not much signal here. Oh. Volume down. This is an unmodulated signal, so we're not going to hear anything. Well, we'll hear that, but we're not going to listen to it. So there we go. We have an interesting image on the screen, which is the appropriate kind of shape. The fact that it's downwards doesn't mean anything. That looks pretty good already. I think if I raise the input or the output of the signal generator, or the input to the radio, we can clean up this thing here. I think. Let me turn it up a bit and we'll just see what happens here. It's getting bigger and bigger. Now, what do we hear from that? And what kind of AVC voltage are we getting? So we're not getting much voltage yet. So I am not driving the set very hard. The AVC voltage goes up higher. I get to know how hard I'm driving this thing, how high the input is, relative to what it can stand. So there we are. Whoops. There we are. That's looking pretty good. What am I supposed to do with that? I can't tell for sure that this is 455 here. The first test indicates yes, 455 is the peak. Could you move that around a little bit? You probably could. Can you get it any better? I bet you can't get this any better. Yeah, I'm gonna set up for another frequency to show up in here so we can really test and see if this is really 455. This is important for the accuracy of the dial on this radio, to get the IF correct. So you know, I'm just going to leave the camera running. I was going to stop, but why bother? So I'm just going to move this over here like so. I'm going to turn this guy back on. Okay. This is a driftless signal generator. It's fantastic. Comes on to the frequency it's set to and stays there. Bingo. Just like I said. Now, the output from here, we need another cord. So the idea here is to mark on the oscilloscope where 455 is. And the easiest way is just to put another frequency into the scope. Into the scope? I think so. So that's what I'm going to try. Because I'm put this here, and then we're going to put this here. Nothing terrible happening. Put that like that. Don't see a thing, or do I? So I'm going to vary this now. I'm going to watch very carefully the bottom of this. Okay, we're going to give it more juice. Ooh, there we go. So usually there's an effect that you can see traveling up and down as you move the frequency up and down. I'm way off here. But, you know, I don't see any effect there at all. So we're going to try this differently then. Instead of feeding it into the scope, which maybe is a mistake, let's turn this down. Get that up awfully high. Just check something here. No, I cannot see anything. Usually there's a little blip that'll travel along here, and if you look carefully you can figure out where it is and what it is. We'll take this off. We're going to join, we're going to feed it right through with the other signal level even lower here. Okay, watching the scope. Let me just move this a little bit this way. Okay. There. Okay, nothing much happened. This is very low output. You may not see anything. Okay, I'm going to raise the output here. There we go. Now you can see an effect. You can kind of see something happening too on the camera, even though you're a little far away. I can actually spot the spot. The spot is right here. The spot is right here. The spot's gone somewhere out there. I'm changing the frequency. My other hand over here. That's why the spot is moving. So I will set the spot right at the bottom of that peak. Right there. And what frequency do we have? You see that? 455, 456. Right on the money again. So this radio has come to me in better shape than virtually any other radio I've ever worked on. Yeah, hats off to the guy who had this last. Or is this thing just so stable that it's maintained its possible. This is right out of the factory. Kind of doubt it though. Okay, so there's nothing to do. There's no alignment work to do here. The check is over. The radio has passed with flying colors. Okay. Okay. Let me, before I make a mistake here, let me just turn a few things off. Like, for instance, the radio itself. This guy, this guy, this guy. This guy. That usually happens after I stop the video. All this snapping of stuff off. Okay. Well, okay, so tomorrow what I'll do, since the IF seems to be just fine, I'm just going to go down through the alignment procedure, following it as it's written in the document, which is do whatever's next on the list, and work our way through everything. So, but so far, this is really a wonderful radio. So far. Mr. Hammarlund, good job. So thanks a lot for watching, and I'm off to enjoy a beautiful day outside. See ya.